Earlier, there was one application which caused so much of friction between development and operations team. Now that has just been multiplied by 20, because the same application you broke down into 20 microservices. So same challenges multiplied by 20, and that is a challenge when you are deploying microservices. So you need a way which helps you deploy those microservices in an easier way, in a more predictable way, in a repeatable way. So that you don't end up into problems where developer says that, hey, this works on my machine, but we need microservices. That is the way to go today, right? Now, that is where the whole Docker philosophy, that is where the whole paradigm shift of container comes. Run any application anywhere. Today, if you are deploying them on physical machines, same thing you should be able to take into cloud and bring them back on-prem virtualization, or move to OpenStack, or move them to another cloud vendor without any problems. That is what an operations team wants to achieve today, so that you don't have any kind of lock-in. I would be trying to demonstrate how you can make an atomic image. I use this term atomic because an image is self-sufficient. Everything that is required for a container to run would be part of your image. So let me try to show you an image here. So I have tried to build my own Docker file. So I was playing with Jenkins, so I thought, why not run Jenkins in a container? So I reached certain configuration in Jenkins, and every time I had to set up a Jenkins demo for a customer, I always used to go and set up Jenkins from base image, and then go and do some modifications, some changes in the configuration. So I thought, hey, why not put everything in a Docker file so that my demos are repeatable? So tomorrow, if I have to set up Jenkins for a customer, I just have to say Docker container run or Docker service create, and that will create my demo environment. So that is what I did. So I'll just show you my Docker file. So in my Docker file, what I'm doing is I'm trying to start from a base image. So that is what you do. Typically in any kind of Docker file, you will start from a base image, and on top of that base image, you are going to add more and more features. So look at my Docker file. I'm trying to copy different configuration files, and then I'm running certain commands to set up my Docker file, to set up my container. And then I'm also specifying what has to be run in that container once it is fully baked. So let me try to do that. Let me try to use this Docker file and do a build. So what I'm going to do is I'm going to do a new build here. So I'm tagging my Docker file as my Docker Hub user. I have a repository called Jenkins master, and then I'm going to push my image over there. So let me just log in here. So it is doing the whole build. Everything that I have specified in my Docker file is being executed right now, and all that is going to copy it in the final image that I have set up, and then tomorrow I can just use that image and run that image. Okay. So I'll just wait for it to finish. So this is almost done. So I'll log into my Docker Hub account. And now I will be trying to push this image. So I'm pushing this image, and let us take a look at my Docker Hub account. I had pushed this image a while ago. Now I'm updating it, so this should get modified now once this push is completed. So you'll see that while I'm pushing these images, my image that I have built just now, it says in a lot of places says layer already exists. So Docker works, containers or the container images, they work based on overlay layers of file system. So every command that you saw or every step in my Docker file, it creates a new layer. So the base layer, and then every change introduces a new layer. It will try to push a layer only if it has been modified. So if the layer remains same, it is not going to get pushed again. Same applies when you're trying to pull an image and run a container using that image. So imagine trying to clone a VM, or you have a clone of a VM and trying to restore that VM. It at least takes a couple of hours. Restoration itself just takes a couple of hours if you have all binaries and everything installed. In this case, it is going to be very fast because a lot of things will be already existing on your machine. A lot of images will be, a lot of layers will already be existing, and it will use the content cache. So you don't have to worry. And this has been, all has been pushed now. So let me refresh. So you can see it has been pushed just a minute ago. It's been pushed just a minute ago. This image was pushed. And then I can use this image and deploy my Jenkins containers. I can deploy my Jenkins CI/CD pipelines with all the configuration that I wanted to do related to security, all the configuration I wanted to do with respect to plugins that I want in my Jenkins environment. Everything is now baked into this image, and then I can just deploy it. So it is very easy for me to get started with Jenkins again for my next demo. I don't have to do the manual configuration at all. And this way, let's say if I do some changes in my configuration, I'll again bake a new image and push it. So I'm also able to version control my configuration changes. So you can, I'm using latest tag just for the sake of demo, but you can use a better way of, you can use your git hash as your tag, or you can use date time as your tag. So you are also able to version control your images and configuration changes. Now, I spoke about running containers. Eric also spoke about how just the Docker engine is not enough for you to run your containers securely or at enterprise scale. What happens when you're running a container just on a single node? If you're running multiple containers on that node, what if that node goes down? What would happen to all your containers? They will also go down. You want a mechanism so that if your containers go down, they should get restarted. If your node goes down, all the containers on that node, they should also get restarted. You want a mechanism so that you can take a node out which is running some production workload. You should be able to take it out, perform some kind of maintenance. You're trying to add a OS patch, kernel patch. You're trying to update the Docker engine itself. Any kind of patching, you should be able to do it easily. But usually with orchestration frameworks in container world, it is not very easy. An operations guy who is trying to manage and maintain a complex cluster can easily end up like this. If you are using an open source framework, you are using any other orchestration framework for containers, you can easily end up like this when you have to add and remove nodes. Spending a whole night in a data center, plugged your computer into one of the sockets and trying to do some operations overnight. So that is one of the things that Docker tries to make easier for users, and I'll talk about it how. Another thing is, when your whole idea of deploying containers is to go agile, is to deploy things faster. But when you start running faster, you want less security blockades. You don't want anyone to block you for the sake of security, and then things start becoming less and less secure. So security versus agility is always a trade-off. Complexity gets introduced whenever you are trying to secure things. This is an analogy I always give to people. I live in Singapore, which is relatively much safer country as compared to a lot of other countries in Southeast Asia. But still, whenever we go to sleep at night, my wife is very paranoid. What she would do is she would lock all the doors. So what she would do is we have an iron door in front of our at the front gate. She would first lock that, then she would lock the wooden door. She would latch it. She would latch it one more time at the bottom. So if there is someone at the door, I have to open like 3 locks and couple of latches, and then there is an iron door, and then I forgot the keys. So I go and bring my keys, and then I open that as well. So it takes me considerable amount of time just to get the door open. She wants things to be secure, but it is making things less agile for me, right? Pretty much the same experience with everyone, right? If you have a door, how many things you lock every time, right? You already have few doors that you lock, few knobs that you have to turn every time, and you get irritated by the time you are there to greet that person who is on the door. But does that mean that you always have to be that way? No. I mean, to extend my analogy, now there are smart doors coming up, something like what we are using in our mobile. Pretty much everyone uses a mobile smartphone, not just a mobile, but a smartphone, right? A lot of you must be using fingerprint-enabled smartphones, and there are payment facilities built up into those smartphones. Samsung Pay, Apple Pay, Android Pay, Google Pay, and you can just scan your fingerprint and pay. It is secure. Even if you lose your phone, no one can misuse your cards. No one can misuse those payment details. And at the same time, it is also very agile. So that is the kind of security Docker tries to bring to your operations, and we will look at it how. Another challenge is whenever you're running images, how do you ensure the authenticity of these images? How do you ensure that the images that you're going to run in production, your developer has not pulled the base image using something from the Docker Hub which is not secure enough? I just demonstrated an example of a Docker file. What if the from clause of a Docker file is using an image which is not secure enough? If it has some kind of vulnerability or some kind of threat in that image itself which has not been mitigated or fixed. So you can securely run your containers using UCP, which is Universal Control Plane, which is part of Docker's Enterprise Edition. And that offers you both kind of orchestration. You can use Swarm orchestration or Kubernetes orchestration. And you can also scale it up by adding more and more worker nodes of each type. So you can add 10 more Swarm worker nodes, 20 more Kubernetes worker nodes as your operations scale up. You can also ensure high availability for your deployments by using multiple controller nodes or manager nodes. So when you deploy Universal Control Plane, you get a GUI like this. So you get a GUI like this, which will show you how many nodes you have, how many containers you are running, and you can also attach to one of these containers and inspect the logs or check the performance. And in addition to let this load, meanwhile I'll just show you one more thing that you get. So you also will get a client bundle. So this node that I'm showing, where I'm connected, this node is not part of my cluster. This node is not part of my Docker cluster, of my UCP cluster. This is a client node. So think of this node, this screen, think of this as your developer's machine. Think of this as your CI/CD machine on which your CI/CD workload is running. Think of this as your operations team login machine. Your operation team has a jump box. Think of this like a jump box or like a Bastion host where your developers would connect or your operations team would connect, and they would be using this client bundle to get details about your cluster. So I can list the nodes, which all nodes are there in my cluster. I can also say Docker container ls, and this will list all the containers that are running in the whole cluster. You will see that every container is prefixed with the node where it is running. So going back to the GUI, so here you get a complete hawk-eye view of your whole system which is running. Number of nodes that are running, all the containers which are there. So you can look at containers, you can look at nodes, you can look at your Kubernetes deployments, you can look at your Swarm deployments. All of them you can look at them from this GUI portal. You can also deploy a new container. So let us deploy a new container from here. You can run this container. You can deploy a new container, and let us go to our GUI and let us try to see if a new container has been started a while ago or not. So whatever containers I start, they will be started on one of the nodes. We can also list them from here. So let me list the containers. So this container has been started just 36 seconds ago on node 100-60. Yeah, this is taking a bit of time, slightly slower. So, sorry, the internet is only so fast, but yeah, but we can always use the command line. So this client bundle that you can download for a particular user gives you access to the whole setup, and you can just use that, and it is I don't have to log in. I don't have to use a password, which means you can also embed this client bundle into your CI/CD pipelines. It is all certificate based, and this certificate acts like your fingerprint. So every user will have their own client bundle, their own fingerprint, and then all the operations that these users are doing is automatically audited and can be sent to a centralized logging as well. So tomorrow, if operations team has any kind of auditing to be done, they can go back and trace everything back, which user deployed what workload. And this is not just going to work with Swarm, but also with Kubernetes. So you can also deploy Kubernetes workload. Let me show you one of the Kubernetes files that I have here. So I have a Kubernetes Nginx deployment file as well, where I have defined a pod definition. I have defined a new pod to be created, and this also can be deployed easily by using kubectl, which is the client tool for Kubernetes. Oops. So I'm going to use kubectl, and that will also deploy this workload on my same cluster. So in my cluster, I have got 2 Kubernetes workers and 2 Swarm workers. Whenever I deploy, I use kubectl, the workload gets deployed on the kube workers or Kubernetes workers. Whenever I use Docker run or any kind of Docker commands, they get deployed on the Swarm worker nodes. So the workloads are also pretty much segregated and separated, and you can also create within those nodes also, you can tag these nodes as developer nodes or as deployment nodes or production nodes, and then you can attach these tags to specific users or teams, so that developers can only deploy whenever they say Docker run, their workload is only deployed on the developer nodes, and whenever an operations guy is deploying, their workload gets deployed on the production nodes or the production segment. So you can segmentize as well, you can compartmentalize as well, you can create segments within the same cluster. So that is about the orchestration. So this was about, this is what I demonstrated just now. I used the Kubernetes orchestrator to deploy a kube deployment file, and in front of all of these I have a load balancer. So I'm using Nginx as my load balancer. You can use a load balancer that is widely used in your enterprise, or if you're running it everything on AWS, you can use ELB. If you are running on Azure, you can use Azure load balancer, or if you want a software load balancer, you can use Nginx as well, or you can use F5, or you can use HA proxy. So basically, you have your own choice. You are free to use the tools that you are already using in your environment. Now, let's talk about images. So I demonstrated a while ago a use case where I built my image and pushed that into Docker Hub. How many of you are from a bank here? Got a few? And how many of you would be happy if you have to keep pushing your source code and your images to a Docker Hub which is cloud hosted? How many of you can get that past your compliance? I don't see any hands. No one. Right. It's very difficult. It's just not possible because everyone wants to keep their source code, what they are running, secure and safe, and as much as possible on-prem. So what you need is Docker Trusted Registry in those cases, which is again a feature available in Enterprise Edition, and you can deploy you can push your images into DTR. DTR runs as a containerized application on UCP itself. So you can run a DTR application in a UCP cluster. So this is how that setup would look like. You have controller nodes, and on worker nodes there is DTR running, and DTR will be storing all the image layers in a clustered file system. This clustered file system could be S3, could be Azure blob storage or object storage, could be Swift, OpenStack Swift, or if you have any other storage, software defined storage which can mimic S3, you can use that as well, or you can use NFS, which is the most straightforward and simple one. Now within DTR you have a lot of capabilities that Eric covered in detail conceptually, and I'm going to demonstrate some of these concepts. So let's start with let's try to build a new image. So what I'm going to do now is I have another code base where I have a very simple file. So I have a very simple deployment. In this deployment, I'm trying to deploy a very basic Nginx HTML content. So I'm starting with Nginx and I'm adding my own content. I'm also using health check, which is basically something that you can bake into your images, or you can also provide a health check directive when you are running a container. It will basically go and check if your container is running fine or not. If your container is not running fine, it will automatically recycle, which means it will destroy that container and start a new container in its place to take its place. And that is all automated. That is something that is provided by health check. So what I'm going to do now is I'm going to do a new build. So I'll use docker image build command again. And that will initiate a new build. And that build is finished. This time it is comparatively faster because I had tested all these demos yesterday just to make sure that I don't end up being embarrassed standing here if some of the things don't work. So that's why all these images and layers are cached. I believe the Jenkins image, there was some change which had happened recently, and that is why that did the build all over again. But in this case, as you can see, it is very quick because everything was from the cache. So what I'm going to do now is push this image into my DTR, and then I'll show you guys a quick view of my DTR. So again, a lot of layers already exist. Pretty much everything already exists. So let us go back to my. Okay. So over here, I have a repository. This is my DTR. So there is a DTR, like I said, runs as a as a container application, as a containerized application, and it also exposes an HTTP interface, which has REST APIs as well, and plus you can also view it on your HTML browser. So let us go in this one, and let's take a look at the images. So this is the image which was just pushed a while ago, and as soon as I push, I have enabled scan on push on this particular repository. So as soon as I push a new image to this repository, it will start scanning it, and it is telling me there are four critical vulnerabilities, and 14 of them are also major. And I can go and check the details here, which will basically show me layer by layer. So everything that was there in my Docker file, and also everything which was there in the base image, all the layers would have been scanned one by one, and in all these layers it will tell me what are the. So let me just reduce this slightly. So you can see there is a systemd related issue, there is something related to glibc, there is one issue with Berkeley DB. So everything has been scanned, and I'm getting a complete report of everything. And this is all being done offline. You don't have to be online. Your system does not need to be online for these kind of scannings to happen. You can obtain a CVE database from Docker. Once you are a customer of Docker, you are entitled to receive that, download that, and upload that into your DTR configuration. And after that, your DTR will work on scanning offline as well. So this was an example of a push, how you can push. Now, I also have, going back to my repository, I also have a promotion rule, basically which will promote to another repository within the same DTR. So if these checks are met, which is basically, so I don't think that would have been pushed just a while ago, because it does not matches any of those. So I'll go back one more time and then update my So let us view this. Now I have said that do a promotion if the critical vulnerabilities are less than 3. So let us remove this, and I'll say if all vulnerabilities are less than or equals to 30. Not a very safe number to add, but just for our demo, I'll use that. Okay, so new promotion policy has been applied, and let us go here and check if new images have been promoted or not. So you'll see there are new builds which have been just now promoted a while ago. So all these images which were compliant with the new checks I just now updated have been promoted to the operations repository. So this is how you can promote from development to operations or to production repository. And as you can see, I'm also able to modify the tag name. So I'm appending date time in front of the base tag. Base tag was B1 or Ashnik Workshop or B2 or B3, and these tags are also having a prefix of the date time. So I can also ensure if a developer is trying to override their build or their tag, it will not be overridden in this repository. Then, as you can see, all the tags, the vulnerabilities in the source image are also copied over, and the scan report is also available in this repository. I also have a mirroring rule, in my development repo, I also have a mirroring rule which basically mirrors to my Docker Hub account. So let us go and check if this particular site has got any new tags promoted over or mirrored over. So you can see a few seconds ago a new image has got mirrored to my Docker Hub account as well. So you can see that there are quite a few of them mirrored because some of them got mirrored from development. I also have a mirroring policy in my operations repository, so a lot of them also got mirrored from operation. So you can have this kind of chain of promotion and mirroring. So you can say if the threads are less than 20, promote them to operations repository. Once it is tested, mirror them to the Docker Hub. So people who are an ISV vendors, they can leverage this facility to promote their images to Docker Hub, which is available to the world for them to use it. But if in case of banks, you can have a chain of repository, you can mirror them to a DR site, you can mirror them to a distribution centers. There are endless possibilities of topologies that are possible. Now let us try to use these images in one of the deployments. So let us use this for one of the deployments. Okay, so this needs to be started up again. So in this case, I'm trying to use the development image that I had pushed earlier, and I'm going to do a deployment using Kubernetes using a DTR image. Now instead of using an image which is pulled from Docker Hub, I'm going to use an image which is pulled from the DTR itself, and I'm using secrets to store my my DTR login details. And let us do a deployment. So a new pod has been created which is using the image which I pulled from my own DTR, not from Docker Hub but from an on-prem repository. So you can do a deployment which is something like this. You have your worker nodes, and when you deploy, you can deploy using Kubernetes or using Swarm, where images are actually pulled from the DTR, from the on-prem DTR. Now let's go to a stage where you are running containers at scale. So when you are running containers at scale, networking becomes an important aspect and a major challenge. Let's say you have 100 services. How do you set up all these 100 services? How do you make sure that they are accessible outside your container, outside your whole Docker cluster? You would be exposing them on different ports, and then you will use port mapping so that they are available on different ports. Or you can use layer 4 swarm routing mesh, which will basically expose the same port on all the nodes, and then you can load balance across all the nodes. But still, you will have to open that port every time you are deploying a new service, and that again slows you down. Instead, you can use layer 7 routing mesh, which is basically a feature in Docker Enterprise Edition that allows you to deploy containers and map containers to a DNS name or to a host name. So when I'm deploying a container, I'll give it a name like results.app.example.com, and my load balancer will have a wildcard mapping, a wildcard DNS mapping, and then this load balancer will route it to any of the nodes. Let's say it routes that request to node number 1. Node number 1 will identify what container is it talking to. So it will identify it is talking to this particular container, and that request will get routed over here automatically. You don't have to do anything. All you have to do is, when you are setting up your whole infrastructure, set up a wildcard DNS entry in your DNS registrar. In my case, I have done that with Route 53 of Amazon, and then, or if you are not comfortable doing a wildcard entry, then you have to do an entry for every application. And once it reaches this load balancer, it will be routed to a proxy which is running as a service on all these nodes, and that will automatically identify which container it has to route to. So all you have to do is a DNS entry, and every time you are running a container, you have to define some labels, and I'm going to demonstrate that. So I deployed a new service. So service is a way of ensuring high availability, ensuring better way of ensuring health checks and life cycle management of your containers. So when you define a service, you can define that my service is running with 2 replicas, and Docker will try to maintain 2 replicas. Swarm will try to maintain 2 replicas. If one of the container dies because of some reason, let's say the node is down or the container is faulty, Swarm will automatically spin up one more container to take its place. It will always try to maintain this designated state of 2 replicas. The same thing with a slightly different syntax you can also achieve in Kubernetes. Like I demonstrated how you can deploy a Kubernetes pod, you can also deploy a Kubernetes service. And here, if you notice, I have defined this host name. So let us pick up this host name, and let us open that. So my web page is up, and I did not have to open a new port. I don't have to do anything. Everything is happening via port 80. Everything is HTTP traffic. Now I can go a step further, and I have also, what I have done is I have deployed a default service. So let's say demoapps.snakdemo.com. If I do this, I would get an error because I don't have any kind of mapping against this. I should ideally be getting an error, but what would happen usually is what I can set up is every time someone hits a service which has not been defined yet, they will hit a standard "this application is not yet configured" page. Same thing I can also enable with a REST call as well. So instead of returning unauthorized or a not available signal, I can say that this is still under construction. So you can have some kind of downtime page also. And then let me show you very quickly an example of canary applications or rolling upgrades. So this is my first version of my web page. Similarly, you will have a first version of your application. Let's say you are trying to update that. In that case, what you can do is you can deploy a new version. So this was version 1. The name of the application was tweet to us, and this is version 2 of the same application. The name of my service is different, but I have mapped it to the same domain name. And this time again I'm saying replicas is 2. So it is now going to start 2 new containers which is serving new version of my source code. So if I go here and I refresh this page, so I get the new version. Some users will still get to see the old version like this one. Some users will get to see the new version. Okay. Now let's say I have rolled it out, people are using, having mixed reactions, and after a while I realize that the new version is stable and I can go with the new version to all the users. So all I have to do is I just have to scale up and scale down. So I can just use a service update and update the status of replicas from 2 to 1 for the old version, and for the new version I just have to scale it up. So during the break someone was asking me, how can we scale up, how can we add more nodes, how can we add more replicas? This is how easy it is to add more replicas. I just have to update the count of replicas from 2 to 4 and update the service. That's all. Everything has been taken care in the background. And if you want to deprecate your service, you can deprecate your service by rolling it by reducing the count to 0 for replicas. And the advantage of this approach is tomorrow, let's say once you brought down the count to 0, someone comes up and says that, hey, a major problem has been identified in the new source code and we have to roll it back. All you have to do is bring this count again back to 4 or 8 or whatever you want, and bring this count back to 1 or 0, and then no one is using second version, everyone is on the older version which was working fine. So this is how easy it is to do rolling upgrades, and this is just one example. This example also demonstrates how easy it is to add new services without opening any ports, without doing any configuration change. Just by using Docker platform, Enterprise Edition platform, you can get all these features. And all these features that I'm talking about, they are available in the Docker Enterprise Edition advanced version. Some of these features are also available in the basic edition. Sorry, not in the basic, but in the standard edition.